I'm going to do getting some runtime C++ code working. And the basic first steps are going to be taking place in the main.cpp file that we have here, which is the file that will be run when your code is run. This is a so-called entry point, the main where the code starts. And so it's here that we're going to be initializing Runtime Compiled C++, and it's where we're going to be doing any Runtime Compiled C++ cleanup. The end result of what we're going to be doing is going to perhaps be very slightly different to what we have with the source online. Don't worry about that too much, but the basics of how we set this up should be pretty much the same. So we're going to add here the code for Runtime Object System, which is the main header that you need to include to be using Runtime Compiled C++ in the standard way that it's used. And then we're going to be creating some data. In this case, I'm just going to temporarily miss out the logger. We'll come up to that in a second. So put that in here, and basically we have this Runtime Object System interface, Runtime Object System, and we're creating one of those. And to create them, we're going to have an init and a cleanup for Runtime Compiled C++. So as we have 4 direct declarations here for our hamper functions, we're going to have 4 declarations for Runtime Compiled C++. So we have the init function and we have this cleanup function. And then we're going to put those in at the end. And we'll go over what they do. So basically, this first function, Runtime Compiled C++ init, is going to create a new runtime object system. And here, this is not an runtime object system, which is an interface. This is an actual implementation of that interface, which is the runtime object system. We're going to initialize it. And because I haven't created a logger yet, we're going to pass null through to the initialize function, which takes both a logger and something called the system table, and we'll go into both of those later. If this doesn't work, we're going to, in fact, actually what we should do there is we should delete our runtime object system. We can't initialize it, although we're going to return the program here, so it's going to be deleted anyway. In fact, let's call the cleanup. No, let's not call the cleanup, because the cleanup may do other things which we won't want, such as non-deinitialization, as it were. In this case, we're just going to cleanly delete the runtime object system as the only constructed object. So this does compile, but we want to check that it will actually work. So how are we going to do this? And we're going to do this by initializing fairly early on. And how do we suggest it? We're going to initialize it before, it's going to happen before this while loop. And we can initialize it actually before we initialize the Win32 and DirectX or ImGui. So we can go all the way back here. And do our initialization before we do any other initialization. Actually, I'm going to move it till... No, that should be fine for the moment. We may need to move it later on because there's a possibility that we're going to be doing some ImGui code as soon as we initialize, in which case we want the initialization to happen of runtime compiled after the initialization of ImGui, but we can move that around when we need it. And then towards the end, as we do the cleanup, we want to make sure that cleanup happens in the reverse order to our startup. So we're going to clean up all of these. ImGui destroy context. So since that's when we created the runtime compiled C++ initialization before the ImGui, we're going to clean up here. RCC cleanup there. Okay, so this code should run, but shouldn't do anything much more than we had before, but it's always quite nice to start and try. And here we have an error, but this error is basically telling us that we've called a function without any constructors. And this is probably because we have no runtime compiled classes present. So, no, actually the error here the error is due to the fact that m_b_logger is 0. We need a logger for Runtime Compiled C++, it seems, although that should be corrected. In fact, this is an error with Runtime Compiled C++ that I need to fix. I need to make sure that I'm testing to see whether the logger exists, because we want to have cases where that can be handled. So that's given me a good bug to try and resolve. So debug, I stopped debugging for the moment. So we're going to need a logger, which brings us to the next part of what we're doing. So you see, we were able to find an issue there, which I will note down. Okay, so carrying on for the moment, we need this logger. So the logger file is something that already exists within Runtime Compiled C++. So I'm opening up my directory, and inside Runtime Compiled C++, if we go into our examples and there's a console example, we should find this stdio log system. So we're going to copy this over, and we're going to dump this into our own folder, because we're going to make some changes. So we want it in the base directory. And then we're going to add this to our project. So here we go, add existing item, because it already exists. And we add these two. You can actually drag and drop as well. So let's just check the header for this. Looks reasonable. Here we just need to mention iCompiler logger as the it's changed, and we have set up the full paths point to the runtime compiler. And if we go to this stdio-logger.cpp, this is looking reasonable here. And we're noticing that it outputs to the debug string. So here we're going to see the output of our logger within Visual Studio if we're debugging with Visual Studio. It also goes out to standard out as well, which is less useful on Windows unless you have the standard out present, as we do in this particular example. So to get this working, I'm going to include this stdio log system.h, pretty much as we were doing in the example here. So I'm going to place that underneath Runtime Compiled, and then we're going to add a static logger. I'm going to place the header for the logger system in front of these data. And then we're going to pass a pointer to the logger through to the runtime object system initialization. And then that should get rid of that crash happening on dereferencing the logger. Right, and we should also see that it has output that error message or information message that there were no constructors. And over here in the output window, we should also see that it's logged it to here, so that you can see it in your Visual Studio browser. It's very useful having the runtime compiler being able to send output to Visual Studio, because when you get errors in compiles, you can double click on those errors and it'll take you to the file and line of that error so that you can fix that. Okay, so now we need to actually get Runtime Compiler updating itself. And the reason for the update is that it needs to check whether there have been any file changes. And if there has been a file change, we need to compile it, and then we need to load it if we have a finished compilation. So the function for this is fairly straightforward. Basically, we check the status of any compile by taking our runtime object system pointer, getting whether it's compiled, and then loading that module if it is finished compiling. And every frame, we get hold of the runtime object system, and if it's not compiling, notice that there is an exclamation mark in front of this. If it's not compiling, then we call the file change notifier update function, passing it a delta time, which is the time difference between when we last called it, which is equal to, in this case, we go 1 over the frame rate, the current frame rate, which we're getting from ImGui. In this case, you could be using your own timer if you want to do that. And by passing this delta time in, the reason for this is we want to make sure that if there's a number of files that have been changed in quick succession, for example, if you do Control-Shift-S and save out multiple files from Visual Studio, you want to trigger the compile only after they've all of them finished. So we basically make sure that there's been about a 0.1 second delay between us having observed that a file has been changed and then actually calling a compile. So if files are continuously being saved out, we just wait until all of the files are finished saving out and then go, okay, no files have been saved for 0.1 second, right? That should be finished with all those saves. We're going to launch a compile, and a compile is then launched automatically. That'll then trigger this runtime object system, get its compile completed, and then we can do a load. Notice that we do the loading in your own code. This is something that you have to trigger. And this would allow you, for example, if you wanted to, you could save state here, and then you could load state afterwards. Now, Runtime Compiled C++ has its own system for doing that, so we're not going to be doing this manually. But if you want to use your own game engine's save and load of state, then you can use that there. And once again, we're going to do Control F7 in this case, just to check it compiles, and F7 to check the whole thing builds, and then basically run it. And we're not seeing anything happen, but it is not erroring. Right. We now get to the point of making, we actually didn't call that. So let's just add the call to this. So this is the update function that we need to call. And we need to call that within the main loop that we have. So here we have our while. And in this case, we're going to put it after the translate and dispatch of messages from Windows. So I'm going to build it once again, run it once again, actually checking whether that update loop works, and that does appear to do so. Close that window, and now we can look into making the code that we want to make. So the way that we use Runtime Compiled C++ is that we keep the main.cpp file as what you can think of as essentially a launcher. Alternatively, you have a large engine already, then all of your engine code remains pretty much the same, and you start adding runtime compiled C++ code that can be updated at runtime to your project. So we're going to be adding a new file. So here we go to add a new item. Actually, I'm going to add a new filter. I'm going to call that runtime compiled. And so into this folder, we can add code, which is a new code. It's going to be a CPP file. I'm going to call it the same way. And just to make sure we call it the same way, I'm going to copy that. And yes, it's going to go into this base directory here. I'm using a filter in the actual Solution Explorer, but it can just live on that base directory. There's not that many files in this particular case. And we're calling this Runtime Compiled C++ main loop. This is because the loop that you saw in our main.cpp, we're going to move that loop into this Runtime Compiled source file so that that main loop will run within there. Okay, so now we have an empty bit of code, and I'm going to copy and paste this over, and we're going to go through what all of these lines mean. So we're going to include the object interface per module and include the definition of something called iObject. These two lines are pretty much necessary for using Runtime Compiled C++. The object interface per module is an interface that allows us to communicate from the main code to our Runtime Compiled C++ code. This header has objects which are built into each new compiled module, where a module would be the dynamic link library in the case of Windows. And so basically when there's a new code, this code is then built into a DLL on Windows, and then that DLL is loaded, and this object interface is how we can communicate with that DLL and with our main code. We're then going to define this interface ID, and here it's called interface ID run console example, and you'll see that in the code online as well. That's a a holdover from the fact I borrowed this from the console example, but actually we should call this RCP DirectX11 example or something like that. And similarly, we should do the same here with this enum. And basically what this is a number which allows us to identify the different classes that we're going to have in our code, so that you can use essentially a dynamic casting system and a system for creating objects. However, in this particular case, we're not going to use that because we're only going to have one file. And also we're going to show you a slightly easier way to handle having runtime compiled objects in your code through something called a system table. And this can be a little easier to use than using the object factory system and this dynamic casting system. We then have a single class. Here you'll note I use struct instead of class. That's because structs are essentially default public classes. And since this code lives in a source file, it's actually not exposing its insides to anybody other than this source file itself. And we need to have an object because that's the method through which Runtime Compiled C++ works. So this struct is going to derive from this templated class here. And this templated class takes two parameters. The first of which is the enum that we used earlier. And the second which is the base class for Runtime Compiled C++ objects, which is just iObject. Should have had a better name, but I kept the same for backwards compatibility, as we have been mentioning, as I've been mentioning. And so this is somewhat necessary in order to make sure that Runtime Compiled C++ has the basic information it needs to be able to reconstruct, create, and do serialization, etc. of these objects. And we'll see how that goes as we add more code. And every Runtime Compiled C++ program that uses Runtime Compiled C++ will require at least one file that has this an object that derives from iObject and a register macro, of which there are a few, but there's in particular this register singleton macro, which takes the parameter of the main class and then a second parameter as to whether to construct this automatically. So register singleton basically just means that the Runtime Compiled C++ object factory will create a single and only a single instance of this class. And in this case, it will do so automatically at program startup and whenever new code is run. So if I compile this and then run it, what we should be able to see is that it created one new constructor. That was the auto creation of this Runtime Compiled C++. And it did some serialization, which we actually don't have the code for it plugged in at the moment. And it swapped objects. In this case, it swapped from no object to an object. So Runtime Compiled C++ seems to be working in this case. We also see this is happening over here in our left-hand window. So the output debug stream is also giving us the same information. And if we save this file, we will note that it gets caught. There's some compiler output, and then again, object swap complete. And quite handily, I can show you what happens if I add in some error. So here I'll just type some random stuff. This is non-working code. And then you can see that I can double click on that and it'll give me the line and file of which it's got the error. Syntax error, a missing semicolon before this. Well, in this case, it's I love the fact that missing semicolon usually means that somewhere earlier in your file you've got some mistake. That's the actual mistake. And so saving that out. And that all works. So this is Runtime Compiled C++ in its most basic, but in this case, it's not doing anything useful for us. So we need to make a step beyond that. So there's more explanation in our tutorial and links through to wiki pages on Runtime Compiled C++, which explain some of the more information about runtime modifiable classes. And there are many links to different aspects of this.